Hello students, my name is Vaibhav Mishra, I am your physics teacher and today we are going to see a concept called wave nature of light and how the light energy is propagated. So there was conflict between Newton's corpuscular theory and Huygens wave theory. Huygens win because that theory was able to explain all the phenomena. How so? That we are going to learn in today's lecture. So Newton proposed light is a particle made up of particle and Huygens proposed light is made up of wavefront. Now what we are going to see is what exactly is a wavefront. So this is the first picture that I want to show you, created an animation for clarity. So this is, what is this to look like? If you throw water in the pond, then the water ripples are formed. So this is a kind of propagation of energy. Same way, the light energy from sun, it comes to earth again with the help of some definite kind of wavefront, that's called wave propagations. Energy is propagated in the form of wave, that was confirmed by the Huygens theory. So what exactly is wavefront, how wavefront propagate energy, how wavefront is formed, that we are going to see. So see, what kind of wavefront is formed and what exactly is the wavefront, we all learned in this lecture. So what is the objective of today's lecture? We will try to understand what is Huygens principle and how the Huygens principle explained a primary wavefront produces secondary wavefront, secondary wavefronts is used to propagate the light. So let's see. So depending upon the type of light source, the type of wavefronts are of three types. One is a point source produces spherical wavefront as you can see in this animation, and a line source like a tube light or a small bulb, small tube light produces a cylindrical wavefront. This shape is called wavefront. So to see it clearly, when we throw a stone in the water, what happens, the water ripples are formed and this definite shape that is formed is called a wavefront. So to look it very clearly with this animation, perfect. This point where it impacted called as point of impact, it generated a ripple, a wave, and the wave is propagating and those particles come back to rest. Now Huygens proposed any particle which lies in same phase, oscillate in same phase means same time go up and same time go down, they are called in oscillating in same phase, and the joining all those points which oscillate in same phase, their locus is called a wavefront. So wavefront is nothing but locus of all the points which oscillate in same phase. This is example of that water, when we hit from the stone, water ripple came, all the particles of water go up and down at the same time. As this water, the stone comes to the bottom, comes to rest, the ripple stops, which means the source of the wave front is gone. But the water keeps on traveling, the one which was produced here, it keeps on traveling, and that's how energy is being propagated and water is oscillating back and forth, up and down. So now if we see, this concept was beautifully explained by Christian Huygens. Newton proposed his particle nature, particle theory called corpuscular. Huygens proposed up till 8 years, everybody believed that Newton was right, but Christian Huygens actually explained all the phenomena related with the optics. So now let's see with the example, this also we do in higher classes in the lab experiment, a laser source. This is a small point source, a light passing through this point source is coming out in the form of a spherical wavefront in three-dimensional structure. So if it is a line source, then line source produces a cylindrical wavefront which is spreads in three dimension beautifully in all the rest of the cylindrical wavefront, that was spherical wavefront. Depending upon the shape, their intensity formula will be different, that we'll see in later. The third type is wavefront, for example sun. So any cylinder or any sphere, when it becomes very large of infinite radius, it becomes like a plane surface. So the light source coming from sun to earth is coming like a plane wavefront because it is so far that it becomes a sphere of infinite radius. So now let's see how the secondary wavelets are formed from a plane primary wavefront. A point source produces spherical wavefront. Any point which is equidistant means same time it will reach at the same time, those will be in same phase. So here point A and point A dash, they are at same distance because light travels in all the direction, they are in same phase. If we join A and A dash, every point which lies at this distance will be in the same phase. Joining them will give one wavefront. Now, according to the Huygens principle that Huygens proposed way back in 1600s, every point on the primary wavefront produces a secondary wavelets with the same speed as a primary wave. So all the particles, they are producing their own secondary wavelets. These are called secondary wavelets, which propagate only in forward direction as per the Huygens wave theory. They are at the same distance because again secondary speed is also same as primary. At particular time, they all will be at the same radius of a sphere. If you join them, this will be exactly same distance, same radius because speed is same. According to the Huygens principle, on the secondary wavelets, if we draw a common tangent, you can see the small lines, these are common tangent. Joining common tangent to all the secondary wavelets, if we join them by a common tangent, that will give a new wavefront position. That's how first wavefront primary, then secondary wavefront produces another wavefront, then that makes another wavefront, and so on and so forth. The light energy is propagated. So that's a primary wavefront. Each point on the primary wavefront acts as a source of secondary wavelets, which spread out at the same speed. Secondary wavelets, after a certain time, if we join all these points which are on the secondary wavefronts, that makes a new wavefront. That means energy is now propagated from previous wavefront to this wavefront. So this is a geometrical construction method by which Huygens actually explained we can predict where will light reach and in how much time, and there were different terms associated with it like phase difference, and that's how energy is propagated. This theory was proposed by Huygens, but later on it gave exactly perfect result. Foucault did an experiment, Thomas Young did an experiment, that all we will see in this lecture series. So again, just to recap, you can see how beautifully the light energy is propagated. Now if we see backward, the backward propagation of light does not happen because only in forward direction light energy propagate, the backward energy gets cancelled out, and this was beautifully explained by Fresnel, another scientist. The light only propagate in the forward direction. Amplitude of secondary wavelets at a distance theta, where the phase difference is theta, is given as A plus A cos theta, so that's proportional to 1 plus cos theta. In the opposite direction, as you can see, a primary wavefront is coming and secondary wavefront is going in opposite direction. Angle between them is 180 degree, and as we know, cos 180 is -1, so that energy get cancelled out. From the primary wavefront, energy only propagates in forward direction, forward direction, forward direction. That's why light energy propagate only in forward direction. All the phenomena, refraction, reflection, interference, diffraction, that all we will see in this chapter was explained beautifully by the Christian Huygens wave theory. So, summary, what is a wavefront? A locus of all the particles in a medium when oscillate in same phase, those are called wavefront. Every point on a primary wavefront acts as source of secondary wavelets. Secondary wavelets spread out at the same speed, and a common tangent drawn on the secondary wavelets form the new wavefront, and that's how the light energy is propagated in the forward direction only. So this is the today's lecture in which we saw with the help of an animation how the sources produce energy and propagate the light energy with the help of wavefront. Thank you.